Okay, well, we're moving back to the 2004 problem, finishing that up. I'm going to get my pen here. And it asks us to calculate the value of KSP. So, plugging in these values here into the equilibrium expression gave us KSP is equal to 9x squared. Well, if we can get x, we are home free. So let's look back in the previous example and see if they gave us x. It says that the concentration of Ag is 5.3 times 10 to the negative fifth. Okay, the saturated solution of Ag. Remember, saturated means at equilibrium. Okay, so at equilibrium, the saturated solution is 5.3 times 10 to the negative fifth. That's for Ag. Well, let's go back and look at what that means. That means that 3x equals 5.3 times 10 to the negative fifth. So that means that x equals 5.3 times 10 to the negative fifth divided by 3 in this case for x basically. So we know that the concentration of Ag plus 1 equals 5.3 times 10 to the negative fifth, and we know the concentration of PO4 3 minus in this case is this value, which is 1.8 times 10 to the negative fifth. And we're going to plug that into the equation, and you can do a couple things. You can plug this value, or you can plug this value directly into there, and this value directly into there, or you can plug the x directly into this equation. However you do it, you end up with the same answer. KSP is equal to 2.6 times 10 to the negative 18th. Not that soluble in this case. Well, moving on to G, the very last problem. I'm going to have to erase this again in order to get going, so I do apologize. Hello, erase. There it goes. Alright, I got enough room now. Okay, so G is kind of a trick question. It says, in a 1 liter sample of saturated Ag3PO4, the solution is allowed to evaporate at 25 degrees Celsius to a final volume of 500 milliliters. What is the concentration of Ag plus 1 in the solution? So whether you had 1 liter or it evaporated to 0.5 liters, the concentration of Ag is independent of the amount you have. Okay, so you can kind of think of it as thickness. Okay, the thickness is going to be the same whether or not you have 1 liter or 0.5 liters. That's an intensive property of matter. So 1 drop, 1 liter, 25 liters, 100 drops, whatever, the concentration of Ag is going to be what it was in the previous problem at equilibrium, and I believe that was 5.3 times 10 to the negative fifth moles per liter. Alright, see you guys on 2007.